In this video we're going to use shape optimization to minimize the drag on an Ahmed body. So we begin by using the CFX fluid flow module and right clicking on geometry and opening a new design modeler geometry. We're going to begin by sketching an Ahmed body, sketching the domain, and then we're going to apply some geometry changes and a parameter set to the Ahmed body. From there we'll run a simulation, we'll create an expression in CFD Post, and from there apply the optimization to our geometry. So just view from the Z direction, and we're going to sketch on the XY plane, create a new sketch and create a rectangle with a bias for being downstream. Don't need to be too accurate on the dimensions, something of approximately that scale is fine. And I'm going to extrude that up something in line with this length, so approximately 8 meters. Just make sure you add material and select 8. Just hit generate when you're ready. Now we've got our domain, we need to create our Ahmed body. So I'm going to first of all create a plane offset from XY. And if we just right click on transform here, we can offset in the global Z direction. I'm just going to offset mine by about 0.1 meters. And just hit generate there. Then I'm going to select plane 4 and sketch 2 and create another rectangle. Going to be a bit more precise with the dimensions here, so making sure we've got something coincident on that axis and something downstream. So just adding dimensions, we'll have a length, we'll have a width, and then we'll measure that half width here. So it's going to be about 1044 mil long, so 1.044, about 0.3 wide, and therefore that'll be like 0.15 half width. So it looks a little thin, so I'm just going to make that 0.4 and this one up to 0.2. And then from there I'm going to extrude that, and we'll extrude that to 0.3. I've got sketch 2 selected already, and rather than adding material I'm going to cut material from the domain. So just extruding this and holding the middle mouse button to rotate. Going to select the faces of this domain and right click and hide faces. Note you can also just press F8 if you find that easier, and just zoom in on our shape. So what I'm going to do first of all is create fillets on these front edges, and then I'm going to create the rear slant you expect from an Ahmed body on the rear. So just creating a blend, fix radius, and just moving from box select to single select, and edges 1, 2, 3 and 4. I'm just applying that and generate. And first of all I'm going to hit that little box there, so calling that front. That's going to be our first input parameter. Then going to slightly rotate and just view this rear edge. So this is our rear slant edge. And we're going to add a chamfer to that. So just selecting that one. And to make life a little easier, I'm going to select angle. If we make it 30 centimeters, just see how that looks. Make that left angle even. That was a little bit better. So we've got some initial value of 30 degrees from the left angle and 0.1 deep. Doesn't necessarily matter what these are, we're going to be making these changes automatically in a minute. So just selecting this angle and calling it rear. And these are elements we're going to change in our shape optimization later on. So once you've done that, just hit save and open up meshing. Okay, so I'm not going to create a particularly intense mesh here, and the reason being is that we're going to make some changes to the geometry as the simulations run. So to keep this cost effective, keep it simple, keep it quick, just going to add a quick surface refinement. So viewing from the top and seam to selection, and just selecting a box, select here, find your Ahmed body, right click, insert and sizing. So we've got the faces selected. If we just bring this down to 3 centimeters, just check to make sure this makes sense once it's completed meshing, but again this is more indicative than creating something particularly accurate. And if you're not sure where your Ahmed body is hiding before you make a section plane, just select the region using a box select and then use a section plane. So there we go, we can just cut the vehicle in half and have a little view. And as you can see, we've got our geometry here that's been cut away, and if you just single select elsewhere, what you see is our geometry there. I am going to make that slightly smaller just because otherwise we won't properly capture the flow over this rear slanted face because it's so small. Okay, that seems about right. Again, we're not looking for anything particularly accurate here, just demonstrate the purpose, but that should suit. So again, just shut down meshing, and once you've done that, just right click, mesh and update. Okay, so just opening up CFX Pre. So we're going to go through the usual process of setting up boundary conditions in a moment. Just spin this around and view it from the front. First of all, just having a quick look at the fluid. I'm going to change the turbulence model to SST. Slightly better at picking up rear slant behavior. And closing. So go for the usual process, right click and boundary. So creating our inlet, put it there, and a speed of 30 meters per second, just dropping the inflow turbulence intensity down. Create the sides as free slip walls. That one. And this one here. I'm going to create the ground as a moving wall, just so we don't get a horrendous. I'm going to create the ground as a moving wall, so we don't get a large build-up of the boundary layer. So just making sure it's got the same speed as the inlet. So it's still going to be no slip. It's still going to have some boundary layer build-up. But you can just apply that wall velocity there. And just applying 30 meters per second in just the X direction. we can select the outlet, just being sure to call it an opening on that rear face there, relative pressure of 0 and a low turbulence intensity. And finally, there should only be one surface left, or one set of surfaces, which is the Ahmed body. So just renaming it, calling it Ahmed. And I'm happy to leave the solver controls alone because we're really just looking to demonstrate the optimization tool. If you hit save, close this down and open up Solver Manager, and just set dual precision, and I'm going to select MPI local parallel with 4 processors. When this has finished running, if you just want to shut it down and open up CFD Post, we'll start making some expressions. Okay, so in CFD Post we can see our Ahmed body here. Just going to move this wireframe for the moment, and we can see that on its surface we have the expected pressure field, so our stagnation and separation. I'm first of all going to create an expression for drag. Or actually, I'm going to create it as drag coefficient. So first of all, right click, functions, and force in the X direction. And it's going to be at Ahmed. And this is going to be over half times 1.185 kilograms per meter cubed. So now we need velocity squared. So we can say area average, and just right click in those brackets there. Velocity U. So I've selected area average velocity U there, so it's the average velocity in the X direction, and where we want that is at the inlet. So just right clicking, locations, and inlets there. If you use the right clicking and use locations, you'll always get the correct spelling for the boundary conditions, so that is advised. So just selecting this group for the velocity and putting the square on that, and then now it's just a case of using an area. So we don't have any front projected area tools that I can see, so a simple one to do is just using the area of the entire Ahmed body and dividing it by some number. Just choosing 4 there, doesn't really matter. What we're looking to do is minimize the coefficient, not necessarily some absolute value. So just double checking force on the Ahmed body over half rho velocity at the inlet squared times by the area and some number. Okay, so just applying that, you can see we've got a drag coefficient in the order of 0.01. So from here, I'm going to right click and select as a workbench output parameter, and then shutting this down, we can have a look at our parameter set. So by default, when we select input and output parameters, we get these 2 loops, and they choose our input parameters and then our resulting output parameters. Although this isn't necessarily what we want, we can use a similar tool. Just scroll to the bottom of this tree and use this direct optimization here. And what it will do is automatically link with parameter set. So just right click and edit. So just start by clicking on objectives and constraints. First of all, our objective is to minimize the drag coefficient. So selecting CD, we want to minimize, and of course we've got a low target, but in reality it's probably going to be 0.05 at its current value rather than all the way down to 0. We've got other things, so we've got our front, and that's got no objective to it, but that is something we're going to vary. And then the rear, again, it's got no objective, we want to vary it, and then we want to see what the effect is on the drag coefficient. So there's not much further for us to do. If you just hit save and then update, you can let this run and we'll have a little look at what happens in a moment. So you'll notice that we've begun the optimization by creating some values within a certain range of the ones we've already created. So the software is going to run a simulation for each one of these, and then from there make a decision on what to do next. So it might maintain a smaller range of the rear slant and vary the front, or vice versa. So I'm going to let that run and we'll rejoin when we've got a result. So we're not quite at the end of the simulation yet, but I just wanted to share the progress. So there's some changes been made to the geometry. The initial solution was actually very good. We've made some changes, the drag coefficient has increased, and then we've reached this stage after the initial 10 where further iteration has been done to minimize the overall drag coefficient. So just about to get the final answer out, but this looks very close to what we're finally going to achieve with respect to the front radius and rear slant angle. I'm just going to finish it there. So if you found this useful, please like and subscribe. It really helps us build the channel and help other people find us.